Function notation. A function is a mathematical relationship that relates an input to an output. There are more restrictions to a function. We'll talk about some of them here. You'll study functions more in a later class. A function has only one relationship for each input value. I'll talk about that more later. The collection of all possible inputs is called the domain of the function. The collection of all possible outputs is called the range. Here's an example of a function. This is read, f of x equals 2x plus 5. Now you might think that because the f is right next to the x that it means f times x. It doesn't. F of x is just the name of the function. It's kind of like having a y equals, except that having an f of x says that this definitely is a function. Okay, so this right here is our input. The x tells what's going into the function. And the equation part tells us what happens inside the function. I think of it kind of like a machine. You're inputting a number into the machine, it goes through that equation and comes out as the output. So let's try one. F of 1. That means that you're going to sub in these numbers as your input, or sub those in for x. So I'm going to take that 1 and put it as my input into the function machine. So I will do 2 times 1 plus 5. It becomes the x. So 2 times 1 is 2 plus 5 gives me 7. So when I put in a 1, I get out a 7. F of 1 is equal to 7. If I put in a 5, the x is 5. 5 is my input into the function machine. Goes into the function machine, the equation gets applied, and then comes the output. So f of 5 equals what? Well, if 5 goes into that equation, 5 will get subbed in for x. And the output is 15. Okay, f of negative 2. Again, negative 2 is my input. That's what I put into my machine as the x. So 1 is my output. F of negative 2 equals 1. These numbers, my x values, my inputs, are all part of the domain. These numbers, my outputs, are all part of my range. Notice, it has only one relationship for each input value. That means that anytime I put in a 1, I'm only going to get out a 7. I'll never put in a 1 and get out a 7 or an 8. I'll never put in a 5 and get out 15 or negative 3 or 2. It'll always be a 15. There's only one output that goes with every possible input. F of x equals x squared minus 1. This is not a linear relationship, but still a function. F of 2. That means 2 is my input. I'm going to put 2 in for x. So I'll have 2 squared minus 1. So f of 2 equals 3. Okay, f of negative 7. I put negative 7 in as my input. That goes in instead of x. Negative 7 squared, that's negative 7 times negative 7 is 49. 49 minus 1 is 48. F of negative 7 equals 48. F of 0. 0 squared minus 1. Is negative 1. F of 7. I added this one. I wanted to talk again about this statement. Every input has only one specific relationship. So that means right here, if I have f of negative 7, I'll never get anything except 48. Negative 7 only goes with 48. We'll never go with another number. But take a look at this. I have two outputs of 48. It's okay if two of the same output go with different inputs, but not the other way around. G of x equals 1 over x plus 1. I wanted to do one that had a g instead of an f to show you that it doesn't really matter what that letter is. That's just the name of the function. And again, sometimes I think of this almost as like a y equals 1 over x plus 1. What's the difference? Well, a function has to adhere to the rules of functions, like the input-output thing and the domain and range. Y doesn't. Y can be any relationship. Okay, so g of x equals 1 over x plus 1. Another nonlinear equation. G of 7. That means 7's the input. 1 over 7 plus 1. So 1/8. G of 7 equals 1/8. G of negative 1. This one's interesting. We'll talk about this one. 1 over negative 1 plus 1. Negative 1 plus 1 is 0, so this is 1 over 0. Notice you can't divide by 0, so there's actually no answer for this one. G of negative 1 doesn't exist. Let's do the last one, G of 2. Equals 1/3. Remember I talked about domain being the possible inputs? Notice that since g of negative 1 had no solution, negative 1 would not be in the domain of this function. 1/8 and 1/3 are part of the range of this function, possible outputs. To read more about functions, you can go to this website. In this class, I want you to be familiar with using function notation and what a function looks like, and a little bit about what a function is. But functions will be covered more in depth in later courses.